In this lesson, we're going to learn about properties of radicals. A lot of these properties are similar to the properties for exponents, so hopefully we'll have a smooth transition. Starting off, radical form, you've got, of course, the radical sign. The index is which root you're taking. Square root would be without an index. Cube root, you'd have an index of 3, and so on. And then the radicand is what's under the radical sign. So looking at our properties of radicals, just like we saw yesterday with raising a number to a rational exponent, these can be converted to exponential form, so the properties should look fairly familiar. If you have the nth root of a to the m power, you can switch it around. Property 2, if you're multiplying two roots with the same index, you can multiply the radicands together under one radical sign. Same for number 3, you can put division under one radical sign as well, as long as they have the same index. Rule 4 is showing you the conversion between radical form and exponential form, which we saw a little bit of yesterday. A root can be rewritten as a rational exponent with the index in the denominator. And finally, rule 5, if you have multiple radical signs, you can multiply the indices together, and that's your new index. If that didn't make a whole lot of sense because I was using that high-level vocab, remember m and n are the indices, or plural for index. You multiply those together, and that becomes your new index for your single radical. Our essential question is comparing those exponential properties with the radical properties, and as I already mentioned, they should look fairly similar. So let's start with some basics, just converting between radical and exponential form so you can get used to the fact that these two forms are interchangeable. So example A, we have the square root of 6. The index for this is 2 because it's unwritten, so that becomes the denominator for our rational exponent. So it is the same thing as 6 to the 1/2 power. For part B, everything under the radical is to the 5th power. I'm going to leave it grouped together. This is a power, so that is our numerator. The index of the root is the denominator of our rational exponent. For part C, because the two variables under the radical have different powers, I'm going to split up that 6th root and put it on each power individually. So that negative sign will stay out front. We have x to the 9, that's our power, so that's our numerator. 6 is the root, so that will be our denominator, times y to the power of 3 over root of 6. So of course we can simplify both of those exponents. So our first exponent, dividing each of those by 3, we get 3/2. And our second exponent, again dividing each of those by 3, we get 1/2. Next we're going to go the other way, converting from exponential form to radical form. So this one, remember, the denominator of the exponent becomes the root, and the numerator of the exponent is the power. And of course, when we simplify, we can't have negative exponents. So that negative exponent means I'm going to flip it to the denominator. Since there's nothing left, there will be a 1 in the numerator, and that power becomes positive. Example B, the root for both y and z is 4. So the 2, because it doesn't have a power, will actually stay out front. And I can put both of these together under a 4th root. So under the radical, we'll have y to the power of 3, because that's the numerator for our exponent. Z to the 1st power, because again, that 1 is the numerator of the exponent on that one. Final example on this page, we've got negative 32 to the negative 4/5 power. 5 is the denominator, so that becomes my root. And on this one, because it's a number, I'm going to go ahead and evaluate this and simplify it completely. So that negative 4, that's the numerator of my exponent, becomes the power. And the power can go inside the radical or outside. Because I'm simplifying this one, I'm putting the power on the outside because I want to take the root first to make the numbers smaller before I raise it to a power to make it larger. So we're going to start with the fifth root of negative 32, which is negative 2. So we have negative 2 raised to the negative fourth power. That negative exponent means I'm going to flip it to the denominator. The power becomes positive. And negative 2 to the fourth power is positive 16.